All right, hello everyone. Section 4.5 is factoring special products, and the special products are let's go through our objectives first. Our objectives are A, to factor perfect square trinomials. That would mean that two numbers, the n number. Here's an example here. So if I have, whoop, I'm not working here. So if I have x squared plus 10x plus 25, well, 25 is a square number because 5 times 5 is 25. And when I add up 5 and 5, it equals 10, which is our middle number. So that kind of represents a perfect square trinomial. So if I had x squared plus what? X plus 36, then you could ask yourself what number would go in the box. And that we would figure out, well, 36 is a square number, and I know when I multiply the squares, it would be squares of 6. 6 times 6 is 36, but 6 plus 6 is 12, and 12 would go here. All right, the definition of a perfect square trinomial. We don't have to worry about that, basically, because when you have a trinomial where the lead coefficient is 1, let's see, plus something x plus 81. Well, 81 is a square number. I don't worry about that because when I'm factoring a perfect square trinomial, I just look, my lead coefficient is 1. So if it's 1, I'm just going to set up my parentheses like I normally would do and just fill it in. And the rest will just come back to us of what we need to satisfy that. 9 and 9 I know is 18, so 18 would go in the middle there. Okay, but really we're just factoring this. So then what would you put? I need two factors of 81 that add up to be 18. All right, so then we'd go through it and just say, well, we know it's 9 and 9. And a 9 would go here and a 9 would go here. Then it's factored. Okay. All right, that's basically it. So factoring perfect square trinomials is not a worry. I'm just going to take it for what the lead coefficient here, because that's what tells me what to do. That tells me what to do. If it's 1, I'm going to set up my parentheses and fill it in. If it's not 1, then I got to do the grouping method. All right, nevertheless, let's go on to B. This is factor the difference of two squares. Now, the difference of two squares, give me a second here. The difference of two squares comes in the form of, let's see, if I have a square minus b squared. That's the difference, meaning the subtraction sign, of two square numbers. A to the second power and b to the second power are square numbers. So if I give those values, then I could make something of it. All right, so let's see. If I have let's do something simple, a difference of two squares that we got to factor. And those look like this. I've got an x squared minus 9. Very basic problem. This is a difference, see the minus sign, of two square numbers. X to the second power is a square number. It's raised to the second power. And 9 is a square number. It's like 3 to the second power. And when I go factor this, then I could look at the first term, of the coefficient of the first term, and it's 1, and say, oh, I know it's going to come from a set of binomials. And then I could fit an x here and an x here. My signs would be, well, I could copy down this sign and put it here, and then determine what multiplied to a negative will give me a negative. And the answer to that would be a positive. Different ways of looking at this. Now it becomes really interesting. Okay, now along with that, then I'm going to take my two values of 9 that multiply to be 9 and add up to be what? I don't have a middle term here. I have x squared minus, say, 0x minus 9. This is another way of writing the same problem. But now I've got 0 in the middle because these are a difference of two squared numbers. And if that's the case, then I need two factors of 9 that add up to be 0. And this is really negative 9, if I count this as the negative 9. So my answer would be 3 and negative 3. That multiplies to be negative 9 and adds up to be 0, if you're looking at it this way. All right, so I could put a 3 here and a 3 here, and there's the factorization of it. Okay, and what more does that tell us? I could set up all my difference of two squares in this fashion, where I'm going to have a minus and a plus. Doesn't matter the order it goes in either. I could put plus and minus. Okay, my square number here would be maybe an x and an x because it's raised to the second power. And whatever number is here, that's going to be my value for the constant. So if I'm doing this problem and I write it up as x squared minus, say, 100. And if I'm factoring that, then I see my x's go first, as usual. I got a minus and a plus because that's what happens when you're factoring a difference of two squares. And then put your value here. What's the square root of 100? 10. So a 10 goes here and a 10 goes there. And now that's something important to let you know is when I multiply this together, what do I get? X times x is x squared. Outside is positive 10x. Inside is negative 10x. And last is negative 100. And this is the part that's interesting. It always goes away. 10x minus 10x, that's 0. So I'd have x squared minus 100 when I multiply this together again to check my answer. All right, the difference of two squares is what that's about. All right, let's do some examples here. All right, here's practice problem 1 in factoring a perfect square trinomial, but we don't know that. We don't know that that's coming, right? So I'm looking at this as, oh, I've got a trinomial where the lead coefficient is 1. So I'm just doing this. It really makes life a lot easier if you follow this kind of a rule. The lead coefficient is 1, so I'll set up my parentheses and just load it up with my answer. This is a negative sign here. So a negative times a what equals a positive. And that would be a negative times a negative. And then I've got my number here of 25. What two factors of 25 add up to be 10? And that's right, it's 5 and 5. So there's my answer. I could write it this way, or I could write it as x minus 5 to the second power. Both are going to be useful as far as our answer goes in the coming chapters ahead. All right, so we kind of will remember that. All right, next, let's see, factor, that was practice problem 1. Let's do a few more. All right, here is practice problem 2, letter A. I'm looking at this and now I see a 9 here. 9. Can I factor out a 9 from a 42 and a 49? And the answer to that is no. All right, but now I do notice that I have a 9a squared. This is a perfect square. This is a square number. 9 is a square number because of the 3 times 3 is 9. 49 is a square number because 7 times 7 is 49. So if I spot that, that's wonderful. I avoid doing the grouping method. Okay, so that means, let's see, if I notice that, then I can set up my parentheses this way as well. And then I could look at this and say, well, the square root of 9 is 3, so I'd have a 3a here and a 3a here. 3a times 3a is 3a squared. Okay, my signs now. This is a positive, and this is a positive. Well, if they're both positive in the problem, they're both positive in my answer. And now I'm going to look at the 49b squared. Well, we mentioned 49 is a square number, and the square root of 49 is 7. So a 7 goes here, a 7 goes here, along with this b here and b here. And there, I've derived my answer. Okay, so you want to notice that these are square numbers in the beginning and the end. It'll avoid you from having to do the grouping method, which is 9 times 49. We want to try to avoid it. It's not terrible to do it that way, but, you know, we want to make it easier for you. So if you notice this when you're factoring, oh, these are square numbers. So take the square roots of those and fix up your first binomial anyway. Okay. That was A. How about B? Let's get a B in here. Let's see what that's about. This one is written up as 25 minus 10t plus t squared. And when you get a problem like this that is basically backwards, written backwards, I want to put it in descending order. So that descending order would be t squared minus 10t. Notice I'm taking the sign of that number and putting it where it belongs, and then this is going to be plus 25. All right, so we're going to factor this problem here. And again, this is reasonable. The lead coefficient is 1, so you're not going to monkey around with this other than to answer it. T and a t. This is a minus. I'm copying it down here. And if this is a positive and this is a negative, then this must be a negative, because a negative times a negative is a positive. And there you go. We just did this problem not too long ago, or something similar. 25 is my constant. I need two factors of 25 that add up to be 10. And that's going to be 5 and 5. And there's that same factorization, if you will. Okay, let's go to, how about, let's try letter C. All right, let's try letter C. Where's letter C? All right, here's letter C, and this is our trinomial, and we are being asked to factor this. All right, looking at it, I've got a 16, a 24, and a 9. Can I factor anything out of that to begin with? And the answer is no. But now again, because this is like a meteor kind of a problem, meteor, meaning more to it than normal, like a normal trinomial, because I got a little bit larger numbers with this being 16 and this being 9, and the middle being 24. So I want to check, hey, by the way, are these square numbers at the end? Not worried about the middle, just at the end. And 16 is a square number, and so is 9. So I also know x to the 4th is a square number. As long as it's even, it's a square number. So I could write this to be inside these parentheses. And then I could take my first terms here and make it 4x squared here and 4x squared here. Because 4x squared times 4x squared is 16x to the 4th. Okay? Then let's set our signs. Well, this is minus, and if this is positive here, then this sign must be minus. Because again, a negative times a negative is a positive. And then I just have the 9 here at the end, and I want to know what is the square root of 9. 3 and 3. So a 3 will go here, and a 3 will go here. And then I'm done factoring it. If you look quickly, you could say if you did the outside, 4 times 3 is 12. And the inside is 4 times 3 is 12. When you add those up, you get 12 and 12, which is the middle term here of 24. So it all checks out. Checks out nicely. If you didn't recognize that, then you're going to do the 16 times 9, which is the grouping method. And you can do that too. but it just takes longer. We want to streamline our operations some. Make it easy. Take it easy on yourself. And by thinking, what is this problem and what can I do? All right, that was C. D is a little bit odd. I'm going to show you that one as well. Okay, let's try this one out. And this is letter D, if you want to follow along with that. All right, now look what I've got here, y plus 2 squared. My lead coefficient is still 1, okay? So this holds true to the idea that if the lead coefficient is 1, that I can set up my parentheses, and I'm going to. My first term now is a binomial of y plus 2 squared. So I could put y plus 2 here and y plus 2 here. If I multiply those two together, I get y plus 2 to the second power. My signs, this is a positive, so I'm copying it down. This one's a positive, so, well, they're both positive on that one. No guesswork involved there. Okay, and then finally, I've got 16 here. That's a square number, so I can just put 4 here and 4 here. Okay. Lastly, because I have this binomial added to 4, well, I can combine my like terms in here. So this ends up being y plus 6. And the one on the right here is the same thing of y plus 6. Or I could write it up as how? Y plus 6 to the second power. Okay, either way. I could write this up as y plus 6 raised to the second power. And I'm done with letter D there. All right, check this out here now. We've got a trinomial, and I've got to factor it. All right, so what I want to do with each and every problem is I want to factor out whatever I can to begin the problem. Can I take out any kind of a factor between 27, 36, and 12? And it seems to me the only number we can take out is a 3. So let's take out a 3. If I take out a 3, then what am I left with? I'm left with 27 divided by 3 is 9, x squared, minus 36 divided by 3 is 12, x, and then plus 12 divided by 3 is 4. Oh, that's real good. All right, so now here I have a square number here in the 9 and a square number here in the 4, and same with the x squared. I don't want to overlook that. X squared is a squared number. All right, so that tells me I can set it up as my 3 comes along, and here I'm going to have my 2 parentheses, and I'm going to take the square root of 9, x squared, and that becomes 3x. So I got a 3x here and a 3x there. 3x times 3x is 9x squared. My signs, I'm copying down the minus sign, and if this is a plus sign and this is a negative, then this is negative, because a negative times a negative is that positive. And then I just have the square root of 4 to go. Square root of 4 is 2, and that goes here and here. And this is good enough for my answer. Done with that. And again, if you miss the idea that these are square numbers or perfect square trinomials, then this isn't too bad to do the grouping method with at all. 9 times 4 is 36. The two numbers that'll get me negative 12 would be what numbers? 6 and 6. and they're both negative at that. Negative 6 times negative 6 is positive 36. When I add up negative 6 minus 6, I get my middle term here of negative 12. And then you go on and proceed doing the grouping method, and you'll be fine there as well. Because these are smaller numbers, and we can deal with those a little bit easier. Fantastic. All right, so let's go on to part 4 here, where we're going to do the difference of two squares. All right, let's take the difference of two squares. Here's the difference of two square numbers. And if I know that ahead of time, then I'm going to set and lay down my parentheses and fill it in. Remember, what's our middle term here? Our middle term is 0. So I'm going to have x, x, 1's minus, 1's plus, and then my my constant is 16, so the square root of 16 is 4, so a 4 goes here and a 4 goes here. And we're done with that problem. All right, let's look at the other one. Let me the other one meaning this, 64 minus t squared. That's a difference of two squares. It's a little bit backwards, but that's okay. I'm going to write it up that backwards. All right, so now what's going to go in our first spots here? The square root of 64, which is 8. So an 8 goes here and an 8 goes there. My signs are opposites. 1's minus, 1's plus, because only for the difference of two squares. And then I've got a t to deal with. A t here and a t here. Negative t times positive t is negative t squared. And of course, 8 times 8 is a 64. You multiply this out and you will have a 0 for a middle term. You won't have a middle term, in other words. Okay. All right. All right, here is a difference of two square problems that we have to factor. Make sure we know what we're doing here. So if I'm factoring this, that you can look and say, wow, these are a little bit larger numbers, right? A 25 and a 36. But then think, are these square numbers? Because if you hit that and recognize them as square numbers, then you are going to do the easy way of doing it, which is, you know, they're coming from two binomials, and then I want to take the square root of 25, which is 5. Square root of x squared is x, so I got 5x and 5x. I set up my signs. 1's negative, 1's positive. That's always true. And then the square root of 36y squared, which is 6y. There. And that makes it nicely done. Nicely done. Okay, if you don't do it, if you don't recognize it that way, then it's going to be a little bit tough. What would you have to do? You don't have a middle term here, so that means like a 0. So you do the grouping method, 25 times 36, and then find the two numbers that are the same, they're opposite of each other, that equal 0. But I don't want to put you through that if I don't have to. This is the key to find the difference of two squares. And while I'm on the subject, if I had a problem where it was the difference of two squares, but it's not a difference of two squares, what if the sum of two squares? What if I had x squared plus 4? Real easy problem. Now the short answer to this is it's not factorable. Because when I set up my parentheses, if I think I'm going to be able to do it this way, I would have an x here and an x here. Then I'd have a plus sign here and a plus sign here maybe. Then if I put a 2 here and a 2 here, well, think we're done. But when I multiply this together, I don't have a middle, I do have a middle term now. And that would be this, let me get rid of this here. I would have a middle term, and that middle term would be Let's try it. X times x is x squared, plus outside is 2x, plus inside is 2x, plus last is 4. So now I finally get it as x squared plus 4x plus 4. So you can see this is not the same as this. If you made this x squared plus 2 and this one minus 2, which is the only other thing you could do, well, now you're going to have 0 in the middle. You won't have anything here. And this would end up being minus 4. 2 times negative 2 is negative 4. So then your answer for this is going to be x squared minus 4. But we need x squared plus 4. But all in all, it doesn't work. It's not factorable when you have a sum of two squares. Does not work. Okay, I think you get the idea there. There are some other problems there, but I'm not going to trouble you with them. I want you to practice some of these in the the exercise section. Give you some additional practice as needed. Okay, let's move forward anyway. All right, in practice problem 5, we've got x to the 4th minus 81. All right, and a general rule I want you to consider is whenever we have something that's raised to the 4th or higher power, then we may have a repeated factorization problem upon us. Okay, so let's think of it this way. I've got x to the 4th, which we know we could split up to be x squared times x squared. All right, the lead coefficient here is 1, so I like to follow that rule because it works for us. All right, the lead coefficient is 1, so I'm setting up my parentheses. I'm going to have an x to the 2nd power here and an x to the 2nd power here. All right, it's a difference of two squares, obviously, so I'm going to have a minus and a plus as my signs. And then next I'm going to take the square root of 81, which is 9 and 9. All right? So now we think we're done, but we're not, because now what I have left here is an x squared minus 9. This is another difference of two squares. Okay, and this one is a sum of two squares, so we know we cannot factor this one. Cannot do. Can't do. We can't factor it anyway. But this one we can. So this one's going to be factored again. Here's that repeat factorization. I kind of knew it was coming because of the x to the 4th beginning term. All right, so for this x squared minus 9, I got x and x, minus and plus, and it looks like 3 and 3. And then this x squared plus 9 just is coming along with us as the complete factorization for x to the 4th minus 81. Okay, that's nice. All right, how about practice problem 6? We are talking x minus 4 squared minus 9. All right, so leaving it as it is, then I can split this up. Again, this is telling me my lead coefficient here is 1. So I'm setting up my parentheses. I'm putting my first terms here and here, so that's going to be x minus 4 and x minus 4. Difference of two squares here, so I got a minus and a plus. And then the square root of, or is that right? The square root of 9 is 3, so I got a 3 here and a 3 here. All right, I'm almost done, not quite, because now I can combine my like terms here. So this parentheses here would be x minus 7, because it's x minus 4 minus 3, which is x minus 7, and multiplied to x minus 4 plus 3, so that would be x, negative 4 plus 3 is negative 1. And this is my answer then. X minus 7 times x minus 1. Okay, we're done. We took that binomial and split it up and put 1 here and 1 here. And the rest was fairly easy. All right, in PowerPoint, in practice problem 7 now, this is really a tricky problem, and it goes against a lot of things I've said in the past, where I look at this problem here and I say, boy, this is a 4-term polynomial. So I could go ahead and group that if I wanted. This is what we would normally do with a 4-term polynomial. This is why I feel bad about this problem. But when I do that, it really doesn't work out. It really doesn't do the factoring that I want it to do. All right, so for now, I'm going to ask you to look at this problem a different way. All right, and the way I want you to look at this is to say that parentheses are gone. And now what I want you to do is look at this as a x squared minus 6x plus 9 minus y squared. Because now I'm going to factor this perfect square trinomial on the left. And when I do, let's see, I'm going to work with you here on this so you can see what I'm doing. And when I factor this trinomial here, I've got an x and an x and a minus, because a negative times a negative is that positive. And then I'm going to have a 3 here and a 3 here. And now, if I want to, I could rewrite this to be x minus 3 squared. And the rest of that problem is minus y squared. So I've essentially turned it from a 4-term polynomial into a difference, here's my difference sign, of 2 squares. You agree? That's the trick here. And this is the key part here. The original problem, I saw this trinomial in it, and then I'm subtracting the y squared. But they took the trinomial, factored it, and it became a perfect square trinomial. Well, it is a perfect square trinomial. All right, so now when I go to factor this, this is the parentheses it's going to go into. All right, then I'm going to have a first term here of x minus 3, and that's going to be times x minus 3. Difference of 2 squares, so one's minus, one's plus in the parentheses. And then here I'm going to have a y, and here I'm going to have a y. I'll combine my like terms in each of these parentheses. So this one here would end up being x minus 3 minus y. And that's going to be times x minus 3 plus y. And those are my solutions. Okay, I'm done. That's it. So, key takeaway here is in this area here, singling out that perfect square trinomial with the rest of the problem of minus y squared. Okay, how about another one? Let's try something else here. All right, on practice problem 8 here, I've got a 4-term polynomial, but now I'm inclined to try it. I'm going to try it because I don't see any nicer patterns there that create a difference of, or a perfect square trinomial at all. All right, so here if I factor out the GCF, that's going to be x squared. And then I'm going to put back what's left over, which would be x plus 5, right? And then over here, I'm going to copy down that minus sign, then factor out a 4 on the right side. If I take out a 4, then what's left over is x plus 20 divided by negative 20 divided by negative 4 is positive 5. Okay, so we've got that. And seems to be working fine now. I'm going to take out the greatest common factor, binomial factor of x plus 5. And what's left over is x squared minus 4. Oh, I see. Okay. So now on this one, I can factor that x squared minus 4. It's another difference of 2 squares. So the x plus 5 I'm leaving alone. And then I'm going to factor, I'm using brackets, it's the same as parentheses. And now I can put an x here, minus, and plus, and then it looks like a 2 here and a 2 here. So there. This one I was able to do it using the grouping method, whereas that one before that has that unique look and opportunity to try it. I don't expect you to really master this initially, but my job is to expose this to you, explain it to you. Part of your job is to retain it. And this is what we'd have. Retain it now and in the future, going forward to your next class. Presumably college algebra. All right, so that was example 8 that we could do by the grouping method. All right, lastly, our the objective C here. It's the factor, the sum or difference of 2 cubes. Now notice in B, we've got factoring the difference of 2 squares, which we're able to do. We were not able to factor the sum of 2 squares. All right, so we cannot do that. A squared minus B squared is okay, but A squared plus B squared is not okay. You can't factor that. When we factor the sum or difference of 2 cubes, we can do the sum or the difference. We're able to. All right, this is going to take some explaining to do, so please be patient. What we're talking here is in beginning algebra, we took a binomial and multiplied it to a trinomial. All right, and when we do that, we come up with an expression. All right, so let's say we're going to multiply these two together. I randomly chose this as my figures for a binomial times a trinomial. All right, so if I'm going to multiply this together, I get x cubed plus 3x squared plus 9x. And I'm just taking this x and distributing it to the 3 terms in the trinomial. Okay, now I'm going to take the 3 and distribute it to the trinomial as well. So that's going to give me 3x squared. I'll put it here. Is that right? 3 times x squared is 3x squared. And then 3 times negative 3x is negative 9x. And 3 times 9 is 27. And x to the third. This should be minus 3x squared. Sorry about that. This is minus 3x squared. Where'd I get that? X times negative 3x is negative 3x squared. Okay. Given that, then I'll draw my line and bring everything down that I can. So I got x cubed. This is 0. 9x minus 9x is 0. Then I'm going to bring down this plus 27. All right, so what am I trying to say? In this section here, you're going to get problems like this, cube problems. The sum of two cubes. Remember, 27 is a cube number because 3 times 3 times 3 is 9. So you have to get used to that, the cube numbers. And I'm not gonna go up that high as far as the numbers go. I could say I'm gonna go up to, like 5. Really, it's 125 already. If we could master that. All right. So in essence here now, if this is gonna be my problem, that it'll say to factor this. Well, what do I know about it? It's gonna look like this. My original multiplication problem, a binomial times a trinomial. All right, so this is going to be my problem, and up here is going to be my answer. So how do I go from here to here? And that's the question. All right, so here's how we're going to go about doing that. I've got x cubed plus 27. This is the sum of two cubes. All right. We know now where it came from. It came from a binomial. Let me use red. Binomial times this trinomial. I got a binomial a little bit shorter than the trinomial, a little bit longer. Okay, so now I want to work on the binomial here. Signs first. My signs. I want to have SOAP to help me distinguish my signs. And you only use this probably 3, 4, 5 times tops. Then you'll remember it. The S in SOAP means the sum of the sign that's going to be in my first binomial is the same sign as the problem. So if this is an addition problem, then this is going to be addition here, or a plus sign. My signs between my first and second term here are opposite. Opposite of the plus sign is minus. And then the sign between the second and third term in the trinomial is AP, which is always positive. It's always positive, as simple as that. So there's the signs of my numbers and values that are in this expression. Okay, once we get here, I want to fill in my binomial. What's the cube root of x to the third? The cube root is x. And what's the cube root of 27? The cube root of 27 is 3. And if I scroll up here to that problem that I multiplied, notice I got x plus 3. All right, once I get here, once I get with my binomial, then I've got it made the rest of the way. Because I'm going to take this, what goes here is the first term in the binomial squared. So that'll be x squared. My middle term are these two terms here, the x and the 3 multiplied together, without the distinguishing the sign, because the sign has already been established. It's negative. So this is just going to be 3x. And then to get my final term here in the trinomial, I'm going to square the 3 in the binomial, which is 9. And now this is complete. If I compare it to my original problem up here, you can see they're one and the same. And that's how I'm going to do this. This is how it becomes. All right, no trickery. You know, some of these are written backwards, but if they're addition signs, you can just flip them around. And I'm going to be a little bit on the lenient side here with this. I want you to get this form down. So I'll do example 10. How about example 10? Example 10 is t cubed. And what did I have here? I had plus, I'm going to say minus. T cubed minus 64 this time. and I want to factor this. It's the difference of t cubed, of two cubes. All right, first and foremost, what is important? That it comes from a binomial times a trinomial. Okay, then our next step is to set up our signs. All right, so remember the SOAP, where S is the same sign as the problem. So here in the first binomial, the minus sign is going to be there. The O means the opposite sign that goes in between the first and second term of the trinomial. So that's going to be positive sign because it's opposite of negative. And then the third sign between the second and third term in the trinomial is always positive. So there, I've got that situated. Now I just want the cube root of t to the third, which is t, the cube root of 64, which is 4. Use your calculator to help you find these numbers. And then once I get my binomial, we're on cruise control to success. My first term here is going to be the first term of the binomial squared. So that's just going to be t squared. My middle term are these two terms multiplied together. My sign has been established for that number. When I multiply t times 4, it's 4t. Not negative 4t, positive 4t, because my sign has been established. And finally, I've got 4 that I want to put in the trinomial. Third term of the trinomial is going to be 4 squared, which is 16. And it's done. Okay, that looks like all I'm going to do for you there. And what can I say? Thank you. And we'll talk to you soon. Bye.